All right, moving on to some arc length and some converting from more specific units to degrees, minutes, and seconds. So, first of all, you need to have this little formula for arc length. Arc length is the outside edge of the circle, basically, and that is what's called the S. So it's when you cut a piece of pie out of that circle and you look at the crust on the pie, the edge of the piece of pie. That is your S. Why they call it S, I have no idea, but S stands for arc length. So this distance right here along the outside edge of your circle is the S. The theta in here is your angle, and obviously the R is the radians, okay? Or the radius, sorry, not the radians. Your theta or your angle has to be in radians in order to use this formula. So if it's given to you in degrees, you're going to need to convert it to radians, okay? I just want to show you this quick little applet, if it'll pop up for me. That is kind of helpful for you to understand. This little applet here looks at how when you change the outside edge of your circle, how the angle that is in here has to change as well. And I know this is a little bit small and you might have a hard time seeing it, but I can drag this point right here, and the bigger I make that arc length, the bigger the angle is in there. And you can go all the way around. Again, my arc length is bigger, my angle gets bigger. If my arc length gets smaller, the angle that's cut out is smaller. So hopefully that helps you be able to picture arc length a little bit better. Anyways, this is the formula that we will be using today. Really important to know that your theta must be in radians, your angle must be in radians. Okay? So, first problem, just basic. Your radius is 10 inches, your theta is a half a radian, and I want you to find your S. If you need to see a picture of that, this is what it would look like. Your radius is 10 inches. Your angle in here is 1/2 of a radian. And I want you to find your S. Okay, so again, we will use the S equals R theta formula. I don't know my S. My radius is 10 inches, and my theta is 1/2 of a radian. Okay, now, here's the deal. Radians are kind of magical units, I call them. They appear and disappear when you need them to, which I know seems kind of crazy, but I want you to think about this. You are finding an arc length. You are finding this distance right here, okay? When you were multiplying 10 times 1/2, you would get 5. The problem people have sometimes is what units to put it in. And the units for an arc length are not going to be in inches radians. That's not a unit, okay? So radians are magical. They disappear when you need them to. If you think about arc length, length is measured in distance, and so inches make sense. So the answer to this one would be 5 inches. The radians disappear. They are a magical unit. Okay? So 5 inches there. All right, here's the next one. The tip of a minute hand of a clock moves 3 inches and rotates 30 degrees. And I'm just putting this on here anyway. But the minute hand moves 3 inches, so let's say that that's 3 inches, and rotates 30 degrees. So this angle right in here is 30 degrees. Okay, and the question is, how long is the hand? That's what the question is. And that is this right here, which is the radius. Okay, so again, you will use S equals R theta. Okay, the problem in this case is you have 30 degrees in degrees, the angle in degrees, and in order to use this formula, the angle has to be in radians. So first of all, I need to convert that 30 degrees. And again, to convert something that's in degrees to radians, you multiply it by pi over 180. And when I multiply that by pi over 180, I will get pi over 6. So that's what it is in radians. Okay, so I know that my S is 3 inches. I do not know my radius, but I know that my theta is pi over 6 radians. Okay, so to solve for R, I will divide by pi over 6 radians. All right, those will drop. And by the way, when you take 3 divided by pi over 6, 3 divided by pi over 6 is the same as 3 times 6 over pi. Dividing by a fraction is the same as multiplying by the reciprocal. So 3 times 6 over pi, this becomes 18 over pi. And now you need to think about units, because it looks like it's in inches per radian right here. But if you think about this, again, radius is a distance. It's the halfway across the circle. Distance is not going to be in inches per anything. Distance is going to simply be in inches. So this is 18 over pi inches. If you wanted to get a decimal value for that, that's fine. And you can do 18 divided by pi and get a number, which would be 5.73 inches. Round it to 2 decimal places, please, if you're going to give it to me in decimal form. Otherwise, 18 over pi is great, or 5 pi over 3 inches is fine too. But inches would be your units there. And then the last arc length question. The minute hand of the clock is 4 inches. The tip of the hand moves 6 inches. How many degrees in radians did the hand rotate? All right, so the minute hand is 4 inches long. It moves 6 inches. So let's say it moves, let's say about right there. And I want to know how many degrees and radians turned out. So that's this angle right in here is what I have to figure out. Okay? So, again, you're going to use S equals R theta. So, and I labeled that 6 inches in the wrong spot, didn't I? This should be 6 inches, sorry. Your arc length is 6 inches. It moved 6 inches. Anyways, so your S is 6 inches. My radius is 4 inches. And I don't know my theta. So I will divide by 4 inches. Those will drop out. And 6 divided by 4 obviously is going to be 3/2 if you get an exact answer. What happens is your inches cancel each other out though, your units are gone, and you need a unit for theta. And what needs to appear, the unit that appears when nothing is there, the magical unit that appears will be radians, okay? Also, when you think about it, in order to use this formula, your theta has to be given to you in radians. So when I'm using this formula, it's assumed to be in radians. So there's one answer. Okay, that's what it is in radians. And then if I were to convert it to degrees, in order to convert something that's in radians, 2 degrees, I would multiply by 180 over pi. And when I multiply that by 180 over pi, I will get about 85.94 degrees. Okay? All right, then we're going to look at converting degrees to a little bit more specific answer, which would be degrees, minutes, and seconds form. There are 360 degrees in one circle, we know that. Each of those 1 degrees can be divided into 60 seconds. So when you see this one little hash mark right here, that means minutes, 60 minutes. Okay, that's minutes. So think of how tiny 1 degree is on a protractor. Then you can divide that 1 degree into 60 equal sections, and each one of those is a minute. And then you can take those 60 minutes and divide them each into 60 equal sections, and they would be seconds. So the double hash mark is seconds, okay? So 1 degree is either 60 minutes or 360 seconds, and 1 minute obviously is 60 seconds, okay? These degree, minute, second things are used a ton in anything navigational. Airplanes use them, boats use them, satellites use them, you name it. Anything navigational, directional, whatever, degrees, minutes, and seconds are used, okay? So let's just look at a couple quick problems. First of all, I'm telling you in this first problem that you have 51 degrees, 9 minutes, 21 seconds. Okay, and I want to convert, so basically I have 51 degrees and some change. And I want that change part, that extra part of the degree, instead of being in minutes and seconds form, I want it to be in decimal form. So I have to figure out how much of a degree I have. Well, obviously I have 51 degrees. Then I have 9 minutes out of a possible 60 in a degree. So I have 9/60ths of a degree there, okay? And then I have 21 seconds out of a possible 3,600 seconds in a degree, okay? And that tells you how much of a degree I have there. And I'm just going to stick this into my calculator and add them up. And when you do this, the book will have you give this to 4 decimal places. So I'm going to have 51.1558 degrees. Round it to 4 decimal places, please. So that's that. Then sometimes you're going to go the other way around, where you have 23 and a little over half a degree, 23.587 of a degree. and I want to have that 0.587, that extra part of the degree, in minutes and seconds form because that's a little bit more exact. So here's what you do. This is a little over half of a degree. So if I want to know what it is in minutes, it's a little over half of 60 minutes. Okay? So this is 0.587, what I'm going to do, and multiply it by 60. Okay? And this means that I have 35.22 minutes. Okay, so this is what I have so far. I have 23 degrees. I have 35 minutes right here. And now I'm going to change this 0.22 minutes, this 0.22 minutes right here. So I have 0.22 minutes that instead of being in minutes, I want it to be in seconds. So now I'm going from minutes to seconds, and there are 60 seconds in 1 minute. So I'm going to take 0.22 times 60, and that gives me 13.2. And this last number, this number right here, you will always round to the nearest whole number. Okay? Always round it to the nearest whole in the seconds term. So 13.2, instead of reporting it as 13.2, I will report it as 13 seconds. Okay? If it was 13.7, I would report it as 14 seconds. And just so you know, in your homework, this number right here may come out to be a 0. So you may have to say 23 degrees 0 minutes and so many seconds. That could happen in your homework, just so you know. But that's how this one goes. Okay? So that should do it for today, and we'll see you next time.